Hello students, how are you all? This is Adnan Askar and you are watching my channel Spark Virtual Academy. In today's lecture, we are going to learn about the atomic number, the atomic mass, molecular mass or the formula mass, and then last we will determine that how to find out the atomic structure, and then we will solve some problems which are related to the molecular mass as well. So let's move towards the atomic number. Atomic number generally means the number of protons or number of electrons present in an atom. We have put here or because in a neutral atom, the number of protons and the number of electrons, they both are equal always. So that's why if we count the number of protons or we count the number of electrons, it's the same thing and it is known as the atomic number. However, if you talk about the atomic mass means the sum of protons and neutrons, or we can call that the sum of electrons and neutrons which are present in an atom. However, if you talk about the molecular or formula mass, it's very simple. If we have a certain number of the atoms in a molecule, then sum of all the atomic masses which are present in that molecule is known as the molecular mass or the formula mass. We will solve some problems related to these three, then we will come to know about those in detail. So let's move towards the problems. Examples of determining the atomic structure. In atomic structure, we mean that we have to determine the number of protons, number of electrons, and number of neutrons which are present in an atom. So we have some examples here. For example, we have carbon, we have oxygen, chlorine, and the last one is hydrogen. Remember, the number which is the lesser number or in the lower order, so that is the atomic number. However, the number which is higher, it is always atomic mass. In some of the periodic tables which are published by different publishers, so it might be up and down. However, we should remember that the number which is in the whole number is the atomic mass, while the number which is in the decimal parts or in the fractional parts is known as the atomic mass there. So here you can see there, carbon, its atomic mass is 6, while its atomic mass is 12. Oxygen's, its atomic number is 8, while its mass is 16. And same in chlorine, the atomic number is 17, while its mass is 35.5. And in hydrogen, we have the mass and the number both are equal. So, as we studied in the definitions as well, for example, we are solving the first example of carbon. So here, the atomic number is 6. So, the number of electrons and the number of protons, they both will be same, 6 and 6. In carbon, in the atom of the carbon, we have 6 electrons and 6 protons. However, how to determine the number of neutrons? We have to subtract atomic number from the atomic mass of respective atom to determine the number of neutrons. So, in carbon, we would subtract 6, the atomic number, from its mass 12. So, we would get the number of neutrons is 6 here again. And same is the case with the oxygen as well. Number of electrons and number of protons are 8 in oxygen because its number is 8. However, the number of neutrons will be, its atomic mass is 16, so 16 minus its atomic number, which is 8. So 16 minus 8 means 8. So again in oxygen, the atomic number, number of protons, number of neutrons, and the number of neutrons are equal, that is 8. If we talk about the chlorine, here the atomic number is 17, so its number of electrons and number of protons will be 17. However, its number of neutrons will be, when we subtract 35.5, when we subtract 17 from 35.5 and we get 18.5. So, the number of the neutrons in chlorine is 18.5. And if we talk about the hydrogen, its number and mass, they both are 1. So, the number of electrons and the number of protons, they both are 1 in it. However, when we subtract mass from number, then its neutrons become 0. So, in the atom of the hydrogen, we do not have any neutron. It only includes protons and electrons. Okay, now we have some examples of determining the molecular mass or the formula mass of any compound. Remember, the atomic masses are always given in your exams or in your paper, or you have to memorize some common atomic masses which are used on the regular basis. However, the atomic masses can also be detected from the periodic table as well. For example, we have three different examples here: H2O, C6H12, and O6. The last one is CH3COOH. The name of the first molecule is water, second one is glucose, and the last one is acetic acid. The way to determine the molecular mass is very simple. We have to first recognize the atoms they are used. So we can see there we have two different elements here. One is H, another one is the oxygen. So we have to write down hydrogen and oxygen like this way. And then we have to put the equality. And then in the formula we have two molecules of the hydrogen, so we would put 2. And there is only one molecule of oxygen, we put 1. Then we have to multiply the numbers with their respective atomic masses. The atomic mass of hydrogen is 1, so 2 is multiplied with 1 and it equals to 2. While the atomic mass of oxygen is 16 and 1 multiplied by 16 becomes 16. And finally, the results are added, like 2 plus 16, it becomes 18. The unit of the atomic mass is always AMU, atomic mass unit. Do not forget to miss this unit. Without unit, this is just a simple number. But if you put down this unit, it becomes the mass, atomic mass. So this is the mass of the water. Same is the case with glucose here again. We have three different elements in glucose: carbon, hydrogen, and oxygen. We have to place these like this: carbon, hydrogen, and oxygen. We have 6 atoms of carbon, so we put 6, 12 for hydrogen, and 6 of oxygen again. Then we have to multiply them with their respective atomic masses. The atomic mass of carbon is 12, so 6 multiplied by 12, it becomes 72. Hydrogen's atomic mass is 1, so 12 multiplied by 1 becomes 12. And the atomic mass of oxygen is 16, so 6 multiplied by 16 becomes 96. And then finally we have to add the 3 results, and the result becomes 180. So the atomic mass of glucose is 180 AMU, atomic mass unit. If you talk about the acetic acid, however, it's the organic compound, but you can see there are two atoms of carbon, so we would put down carbon is equals to 2. We have 4 atoms of hydrogen, 3 and 1, so we put H is equals to 4. And we have 2 atoms of oxygen, so we put oxygen is equals to 2. And we multiply them with their respective atomic masses. Atomic mass of carbon is 12, atomic mass of hydrogen is 1, and atomic mass of oxygen is 16. When we multiply, we get the results. 2 into 12, it becomes 24. 4 into 1 becomes 4, and 2 into 16 becomes 32. When we add down these results, the answer becomes 60, and we put the unit AMU. So 60 is the atomic mass or molecular mass of acetic acid, 180 is the molecular mass of glucose, and 18 is the molecular mass of hydrogen. For your practice, you can take some more examples from your textbook or from Google, and you can do a lot of practice on them. So this was all about today's lecture, in which we learned about the atomic number, about the atomic mass, about the molecular mass or the formula mass, and then we solved 2 sorts of the problems. In number 1, we found how to determine the atomic structures, in which we found the number of electrons, number of protons, and number of neutrons present in an atom. While in the second case, we studied that how to determine the molecular or the formula mass, in which we did these examples. If you have any question, you can put down the question in my comment box. And if you need any note or any other help, you can contact me again in the same comment box. Thank you.